Okay, it looks like we're live, so if we just want to start, go through the questions together.
Okay.
So part 2, you fill this part out during your group. Randomly select 5 of the 30 salaries and compute the mean.
So I just went to the random.org and it just gave me some numbers. Did anyone else go there too?
When I went over it myself, I just picked a row and went straight across.
Okay.
And I just dotted on the paper and found 5 random. So
So the numbers that this random generator came up with were 26. So that one was 49,800.
Okay.
And then 22, which is 59,500. And then 25, which was 45,000.
Okay.
And then 1, which is again 45,000. And then 23, 48,300 equals. And then we would divide, I guess, and then we would make sure it wants us to get the mean, which I read through it, so it does.
right.
That was my problem on the last quiz, is making sure I read it through carefully.
Knew exactly what it was asking. Yeah.
Yes. So then you divide it by 5, right? You add the numbers and divide by 5?
Yeah. So did everyone else get 49,520?
Well,
You know what?
I got a different one, but if we all chose different random numbers, I think would come up with a different mean.
Yes. That's
That
right.
is true.
Okay.
So my mean was 39,740.
Oh, from like the dots you did?
Yes, from the ones I chose.
Should we all pick one and?
Yeah, I was just working through another one because I don't.
So basically what this is saying is it wants you all to pick different numbers and then compare your means to show that no matter what 5 numbers you pick, your means are going to be about the same.
Okay.
Oh. So what did everyone get?
My mean was 43,080.
And mine, again, was 39,740.
So are we all supposed to give our means and then? Okay. Mine is 48,780.
780. And what was yours again, Kimmery?
39,740.
40. Okay, and Karina, what was yours?
Oh no. I was adding it on my calculator.
It's gone.
Minus 39740. So my mean was 49,520. Sorry.
And Ruth, what was yours again?
Mine was 4380. So it looks like we have 2 that are all the way to the right, and the 2 that are all the way to the left.
Yeah.
But they all fall within this mean, the graph that it shows. Mm-hmm. They all fall within that.
That's true.
Is that essentially what we were supposed to realize, Kirsty?
It's Kirsty, but yeah.
Kirsty.
And so C says, does your sample mean appear to be unusual? Explain why you think it is or is not unusual. So all of them should have fell somewhere within the graph, and if they were maybe more towards the left or more towards the right, what do you think that tells you?
That it's unusual.
But why do you think that is?
Because it's further away from the mean, which is 46,000.
Yeah, so it could have been just when you randomly chose your numbers that you got higher numbers. So some numbers that were on the high side of all the data.
That's why the more you do it, the closer to the mean you're going to get.
Yeah.
So
yeah, on that one, I put it was more unusual because mine was lowest. You know, mine was really low. It seemed to be a lot smaller than the mean that it had given us. But it was just that sampling.
So would it be categorized as unusual even if it falls within that bell graph?
Not necessarily.
Okay.
It kind of just depends on your definition of what you would say is unusual or usual for this. But if it's within the graph, it's pretty usual, I'd say.
Right. That's what I said. That's what I put. I just wanted to make sure I wasn't way off. But it's more just like a matter of how close to the mean you feel is usual.
Yeah,
but as
so
long as
basically
it's within the graph, it's
basically what this activity is showing you is most of them are going to be pretty close, but it's possible that you could pick higher numbers and get kind of a mean that's higher or lower. And so basically it's just showing you with only 5 samples from the whole data, it's not going to be completely accurate.
Oh.
Okay.
Okay.
Awesome.
So we did D. So if we want to do number 8. Someone want to do that one?
Can we do it?
Okay.
Sure.
Yeah.
Oh, sorry. The Graduate Management Admission Test, GMAT, is used as an admission criterion in many Masters of Business Administration programs. The scores on the GMAT are normally distributed with a mean of 529 and a standard deviation of 113. Consider a simple random sample SRS or N equals 10 students taking the GMAT. So then would we use that formula of the mu equals X? Is that the one?
Well, if you first read the questions, I don't think you're even going to have to use that formula for these ones.
So this is the one that I had to get on and ask Kirsty about because I was getting confused on when it was asking me, you know, if it was normally distributed or not normal, and I was getting confused about when it's normal and when it's not normal. And he mentioned that if it says normally in the question or normal in the question when talking about the mean or the distribution, that it's always going to be normal.
That's right. That I put normally.
So yeah, in the question where it tells you that all the GMAT scores are normally distributed, then you know that the sample means the shape is going to be normally distributed.
Okay.
And that's what I thought, and that's what I put, but then I got looking. See, I overthink myself. So then it says 10 students, and I was thinking it had to be above 30.
So there's
might be off.
there's 2 reasons that the sample mean will be normally distributed. One is if it's above 30, and 2 is if the parent population is normally distributed. So as long as the parent population is normally distributed, the sample means are going to be normally distributed no matter what your sample size is.
Okay, good. Okay.
But if your parent population is skewed, so if it says that the GMAT scores are right skewed, then you would need the sample size to be larger than 30 for it to be normally distributed.
Good.
Oh, okay.
That makes sense.
Awesome. I'm understanding it.
Yay.
Okay. I feel like I need to do it again. Okay.
B. So that was just answered. So B,
Yeah.
how do you know the
because the parent
distribution?
population is normal.
Yeah.
Right?
Right. Yep.
Okay.
So
Okay.
C.
What is the mean of the sampling distribution of sample mean scores for all such samples? And I have 529.
That's what I have. So that's the formula, Minette, that you were talking about.
Yeah, the Q over the square root of n.
No, because
No, that's the standard deviation.
yeah.
Oh, then U equals X minus.
Yeah, so we're just finding the mean right now. The
But
mean
it-
of the
it
sampling
gives-
distribution
Yeah,
of the
the
sample
same as the
mean.
population mean.
Yeah, the population mean, which it gives us in the information above.
Okay.
So it's always the same as the mean.
Is that what the mean?
So did you get that, Minette?
No, so I'm trying to figure out how you got the 529. What is the mean population?
So it's listed right in the problem as the mean,
Perfect.
population mean.
Oh, perfect. Okay.
So that one we're just bringing down. We're not having to calculate or anything. It's always the same.
Perfect.
So the next one, D, is the one that you have to figure out more.
Mm-hmm.
So the standard deviation divided by the square root of the sample size.
Okay, so I got 1 divided by the square root of 10.
Yeah.
Mm-hmm. Yeah. So I got 35,737.
737.
I got 35,737.
35.7.
Yeah,
34.
35.734 is what it would be rounded up.
Yeah, 734. Sorry, I was looking at that wrong. Is that what you guys all got?
My calculator is wacky and it gives me 35.73. Does it round up or round down?
Oh, so yeah, your calculator doesn't go to that third number. It doesn't want to go there.
I wonder how to take that off. Is there a way? Anyone know?
Is it a calculator that's on your computer?
No, it's this one.
I downloaded one on my phone.
Oh, great idea. Okay.
I just have it on my computer. And
Yeah,
you can expand it and it like gets bigger.
You can download a scientific calculator onto your phone?
Mine, yeah, I typed in, it's called Real Calculator. And it's worked.
Okay. Perfect.
I mean,
cool.
if I need a graphing calculator, it won't work, but right now, I mean, it works well for the class.
Awesome. Thank you.
You're welcome.
Good.
Well, that went pretty well.
Did anyone have any questions on that we need to cover before we go to the quiz? Any questions for Kirsty?
No, I think I understand it this time. Of course, that's what I thought the last time. So.
Well, we still did okay. We just got confused a little.
Okay.
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 So are you guys ready?
Sure.
Yes. So
Start
the group
quiz.
meeting one. No one accidentally click on homework.
I actually emailed her, and you get 2 chances anyway, right?
Yeah.
Yeah.
So I just didn't do the first one. I just did the second chance.
That works.
All right.
Okay, we ready, ladies?
Yes.
Okay.
Ready.
Okay.
I love the first 2 questions. They just help me feel good about myself.
Right? You're like, I know I got those right.
Yeah. Okay. Okay, do we want to go ahead and take one at a time, just going around and read them?
Sure, that works great.
Okay. I'll go ahead and do the first one.
Okay.
So when using the, does this sound, when using the when? Are you guys
I think
seeing
the
that?
beginning part is a mistake.
Okay. When taking samples, I'm going to take that first part out. When taking samples of n equals 5, what was the shape of the distributed means histogram when the parent population is skewed right?
Right?
Skewed right.
Taking samples of n equals 5.
So when taking
So-
sample of n,
So samples of 5. You know it's not going to be normal.
I'm going to put
I think it would just mirror. It would still be skewed right.
skewed right is what I would say.
That would be my thought. What do you think, Minette?
I said skewed right.
So then,
Okay.
are we ready for number 4?
Yeah.
Okay. When taking samples of n equals 100, what was the shape of the distribution of means histogram when the parent population is right skewed? So then, because it's a larger sample number, it would be normal?
Yes. That's what I
That's
understand.
what I would say. Yeah.
Yay.
Can we do 5?
Yeah.
Sure.
Using the sampling distribution applet, when n equals 5, what was the shape of the distribution of means histogram when the parent population is normally distributed? I would say normal.
Yeah.
Yeah, I would too. Okay, number 6, then when taking sample of n equals 100, what was the shape of the distribution of means histogram when the parent population is normally distributed? And I would say normal on that also.
Yes. Okay. So number 7. When would the distribution of the means be normally distributed? So choose all correct responses. So the first response is data are drawn from a population that is normally distributed and the sample size is small. The next is data are drawn from a population that is normally distributed and the sample size is large. The third is the data are drawn from a population that is right skewed and the sample size is small.
Nope.
And then the next is the data are drawn from a population that is right skewed and the sample size is large.
I think 2 and 4.
I think it's 1, 2, and 4.
That's what
That's what I put. 1, 2, and 4.
Because anytime it's normally distributed,
The same things before.
yeah. And then the last one would be true because the sample size is large. So it doesn't matter what the sample size is in the first two. It's just because it says normally distributed means it would be normal.
Yeah. And because the sample size is large on the last question, then it would be normally distributed.
Yes. Awesome.
Does that make sense, Minette?
Yep.
Yeah, good? Whoa. Okay.
Okay.
So which of the following gives the best explanation of the central limit theorem? Number 1 says, if the parent population from which the data are drawn is normally distributed, then the sample mean will follow a normal distribution. Second says, for bell-shaped data, approximately 68% of the data will be within 1 standard deviation of the mean. About 95% of the data will be within 2 standard deviations of the mean. And approximately 99.7% of the data will be within 3 standard deviations of the mean. That's a different.
Oh, that was our favorite one from last week.
If the sample size is large, the sample mean will be close to the population mean. That's the large numbers.
The large, yeah.
And the last one, if the sample size is large, the shape of the sampling distribution of the sample mean will be approximately normal. So let's see.
I think it's 4.
Okay.
Which one?
4. large the shape of this.
I got,
That's
what are
the
you
one
saying,
that I
Linda?
thought. She's saying choice 4.
Oh, I couldn't quite hear her.
Yeah, she went out for a moment, but I could see her mouth moving, and then I could see her last say approximately normal.
Sample size is large. The shape of the sample distribution of
Is that the one you were, Nanette, is that the one that you were saying was 4?
4. You guys are coming in and out too. Am I breaking up?
You are.
Yeah, you are breaking up.
But yeah, that's the one that I would say. If the sample size is large, the shape of the sampling distribution of the sample mean will be approximately normal. Is that the one that you guys are thinking?
Yes. Yes.
Yeah, I think so. I'm just reading through them again just to make sure.
Yeah. I know it's not the 2 middle ones, but the
Yeah.
first one I was like, wait, say that again?
Our population. The data chart.
The central limit theorem talks more about the shape.
Yes, and I
The
just
shape of the distribution.
that was the one that was the one of the questions that I asked Kirsty was I wanted to know that I wanted to make sure I understood the difference between the law of large numbers and the sample or the central limit theorem. And the central limit theorem deals more with the shape, and the law of large numbers deals more with the sample, or not the sample, the spread.
Spread.
But the first one doesn't have any mention of the shape.
Yeah.
It doesn't. So yeah, that's what I think is 4, because the shape.
In fact, other than the one that we know, the bell-shaped data for the 68, 95, 99.7 rule, that's the only other one that has any mention of shape.
Right. I don't think it's that.
Okay.
Okay, so number 9. Let x be a random variable with population mean 10 and population standard deviation 6. Suppose a sample size n equals 36 is drawn from this population. What is the mean of the distribution of sample means? So that would be 10.
Yes. Are you hearing us, Minette?
I can hear you.
Okay.
Okay.
Okay. Is it my turn to read? Okay. Okay, what is the standard deviation of the distribution of sample means by 3 decimal points? So this is when we would use our formula, correct?
Yeah.
Let me get back to my paper. Okay, so we use the standard deviation of 6 and the sample size of 36. So we have 6 divided by the square root of 36. I got 1. Did anybody else get 1?
I
That's
did
what I
too.
got.
I did it twice. I got 1. Both
Yeah,
times.
I got 1.
It's throwing me off that it
I
says
know
by
the 3 decimal
decimal
places.
I got 6 too.
Because the square root of 36 is 6. So if we divide that by 6, obviously that's what we're getting.
Okay.
You guys did it right.
Okay,
Is
good.
that It's tricky, but it tells us that.
3 decimal places.
Just for fun, we could put .000, but just leave it. Okay.
So it's just 6, right? That's what I got.
1.
1.
Oh, sorry. My calculator says 6.
Did you push equal?
Yeah.
I'm sure it's, let's see, 6.
Yeah, you know what? You need to press the equal sign after you press the
Because
square.
mine did the same thing. I was like, 6. Oh, wait.
Yeah.
That makes sense.
Awesome.
Perfect. 1.
Okay. So, Manette, you want to go in?
Sorry, are you talking to me? Sorry.
Yes.
Oh, sorry. I'm having a hard time hearing it. So sorry. Regardless of the distribution of population, the size is large and it's greater than 30. What would be the shape distribution of the distribution large?
I would say normal.
Yeah, I put normal.
That's what I was saying.
Because if the sample size is greater than 30, that's one of the rules right there.
Well, I mean, guess you can kind of look to 12 too and see that. I mean, it says what theorem would justify your response to question 11. So you know it's going to be one of those.
Right.
And
Large number.
yeah, when you use, I always felt as I was reading them, as you use either of those, it kind of becomes normal.
Right. So number 12, I would say the central limit theorem.
Yeah.
Because the shape and larger than 30.
Yeah, and it says as the sample size increases and becomes large, the distribution of the means becomes approximately normal.
Mm-hmm.
Okay.
So I think that's true, and the fact that it says what theorem, you know, that kind of gives it away right there.
Right.
Oh, that's funny. I didn't even notice that. Yeah, that kind of does.
Okay, ladies, are we ready?
All right, make sure I click on all of them.
Yeah, I know. Just double checking. Okay.
Make sure everything's
You ready?
Okay. Yep. Here we go.
Yay!
Yay!
Good job, guys.
Awesome.
Nice.
I think that's the fastest we've ever gone.
That was like what was our third
pretty good.
assignment was like that?
Yeah.
Usually
Yeah, it was
we're
like
2
30 minutes
hours.
and we're done.
Yeah, that's awesome.
Oh, wonderful.
Good. Any comments, Kirsty?
I don't think so. You guys seem to be understanding it pretty well. That's good.
Yeah, we did.
Yeah, that time was pretty good. So.
Just because.
That's good.
Awesome. Thanks, ladies.
That was wonderful.
Well, thank you all.
Have a good night.
Sweet. I guess we'll see you Thursday.
Yeah. See you Thursday.
Thank you for attending, Kirsty.
Yeah, thank you guys.
Thank you.
See ya.
Bye.